In this video I want to look at the drawing of a hyperbola using the compass. I've set up here the transverse axis V1, V2, and I've found the two focal points F1 and F2. And the first thing you need to do is find a couple of random points out here to the right of F2. You can measure them, or you can just mark them in as I'm doing here. If you're in a hurry, you can just mark them in like that. I've just labelled them A, B and C here. And the first thing I'm going to do is take my compass and set it in V2 and open the pen out as far as A. Okay, I'm going to take that radius now, put it in F, swing an arc above and below the axis. And you can also take that same radius over to F1 and swing it above and below the axis. The next thing I've done here is set a second radius, the point of the compass in V1, and I've opened the pen out as far as A. I'm going to use then that radius to come from F1, cut the arc above and below, and then go across to F2 and find the opposite points. Now if you continue that using points B and C, you'll find a nice locus of points here and here that will enable you to find the double hyperbola. Each one of these points then is found by setting your compass in the vertex and opening it out to either A, B or C, and then taking that radius, putting it in the focus, and then swinging the arc from the opposite focal points. So for example, the outer one here is radius V2C, center F2, cut that, and then V1C, center F1, cut the arc, and cut the arc there. So just drawn in the double hyperbola here and here. And then I've just put a second piece of information here that might be useful. I've chosen a random point P here on one of the curves. Now the interesting thing about P is that if you take the distance from F1 to P and subtract the distance from P to F2, you end up with the distance from B1 to V2, which is the transverse axis. So that's sometimes a useful piece of information if you were only given F1 to P, P to F2, and you weren't actually given the transverse axis. And just to finish out the sheet, I put a tangent here at the point P, and I found that tangent by bisecting the angle that F1 and F2 make with P. To look at that another way, the tangent at P bisects the angle that F1 makes with F2 joined to P. So again, that can come up as a question where you're given that tangent and perhaps that angle, and now you can see that if you just double that angle, it will give you the line on which F1 is to be found. And then using the construction I showed you earlier, you can work out then, using the transverse axis, where exactly F1 might be.